Assalamu alaikum. Today's lecture is going to be about measurements and its numericals. Our first numerical is 1.1. Express the following quantities by using prefixes. Part A 4.0 into 10 to the power minus 4. Part B 15.0 into 10 to the power minus 8 seconds. Part C 7.5 into 10 to the power minus 7 grams. For this we need a table of prefix. Now these are those quantities which we write in front of SI units so that we can read them quite easily. Like hexa, we can write instead of 10 to the power 18, beta instead of 10 to the power plus 15, tera 10 to the power 12, giga 10 to the power 9, mega 10 to the power 6, kilo 10 to the power 3, hecto 10 to the power 2, deca 10 to the power 1, deci 10 to the power minus 1, centi 10 to the power minus 2, milli 10 to the power minus 3, micro 10 to the power minus 6, nano 10 to the power minus 9, pico 10 to the power minus 12, femto 10 to the power minus 15, and ecto, which is 10 to the power minus 18. For the first part, 4.0 into 10 to the power minus 4, we rearrange the decimal. We move the decimal to the next point. It will become, ये बन जाएगा 0.4 into 10. The similar value for this number 4.0 we can write down as 0.4 into 10. The same thing can be written again, multiplied by 10 to the power minus 4. Now these are both in the power of 10 and this is power of 1. So we can write it down as 4.0 into 10 to the power minus 4 plus 1. So when we subtract or add these quantities, what do we get? 4.0 into 10 to the power minus 3. And what is 10 to the power minus 3? It is quite written as milli. So instead of writing down 10 to the power minus 3, we can write it down as milli. So what we have seen that whatever the value which is closer to 10 to the power minus 4, we have to put those values over here. So minus 3 was closer to minus 4 than any other quantity which is present in the prefix tab. Now part B, 15 into 10 to the power minus 8 second. Now how can we convert this into a quantity which is in prefixes? So minus 8, which is quite close to nano, 10 to the power minus 9. Now for this we rearrange the decimal to right hand side. So 150 can also be written as 150 into 10 to the power minus 1 or 150 into 10 to the power or divided by 10. We can write it down like that. So 150 into 10 to the power minus 8, which is written as it is, and as we have converted 15 into 150, we have written 10 to the power minus 1. So when we add these two quantities, it will be 150 into 10 to the power minus 8 minus 1. That means these two values will be adding up. So the new quantity will be 150 into 10 to the power minus 9 second. Or what can we write down minus 9 as? Nano. So instead of writing 10 to the power minus 9, 150 nanoseconds. Next is part C, which is over here, 7.5 into 10 to the power minus 7 grams. Now, what is closer to minus 7? Minus 7 is micro, I think. Yes, micro is 10 to the power minus 6. So 0.75 into 10 to the power 1, because we have increased the decimal point, and which is added to 10 to the power minus 7, it will become 0.75 into 10 to the power minus 6, because 1 and 7, when they both add up, it will be equal to minus 6. So what can we write instead of minus 10 to the power minus 6? It will be 0.75 micrograms. As we can see over here, micro is represented by a Greek word which is mu. Numerical number 1.2, the length and width of a rectangle plate are 15.6 plus minus 0.1 centimeter and 10.80 plus minus 0.1 centimeter. That means 0.1 is the uncertainty for the length and 0.01 is centimeter is the uncertainty for the width. Respectively, calculate the area of the plate and its uncertainty in it. We have the data first. The data is length, we have 15.6 plus minus 0.1 centimeter. Width is 10.08 plus minus 0.01 centimeter. We have to prove what is the area, and we have to also find out what is the uncertainty in that area, the change in that area. Solution. To calculate the area of a rectangle, we have a formula. Area is equal to length into width. So we have a certain length which is 15.6, which we are not confused with, which is not basically uncertain, which is certain. So 15.6 is multiplied by 10.8, which is also a certain part of width. हमें ये पता है कि 15.6 और 10.80 ये दोनों वैल्यूज जो हैं ये हमारे पास अनसर्टन नहीं है बल्कि सर्टन वैल्यूज हैं, इसलिए द एरिया ऑफ दीज वैल्यूज आर 168.48 centimeter cube. So the area which we know perfectly is right, which is 168.5 centimeter cube. Now for the uncertain part, we'll calculate the percentage uncertainty in the case of length. What do? We divide the uncertain part, which is delta L, by a certain part, which is L. So what was the value of L? It was 15.6. And what was the uncertain part? It was 0.1 centimeter. So what do we do? 0.1, which is the uncertain part, divided by the certain part, which is 15.6. We multiply it with 100%. What do we get? 0.64%. This is the uncertainty in length. Similarly, the uncertainty in the case of width, which is the uncertainty in the width divided by the certainty in the width multiplied by the 100%. What was the uncertainty in width? We had 0.01 centimeter. And what was the certainty in the width? It was 10.80 centimeter multiplied by 10 to the power, or sorry, 10 to 10 per 100%. That means 100 divided by 100. What we have the values is 0.09%. Now these are the two uncertainty percentage. One was in the case of length, one was in the case of width. Total percentage uncertainty in area, we add these two uncertainties in the case of length as well as in the case of width. Percentage uncertainty in the length plus percentage uncertainty in the case of width. What do we have the values? The percentage uncertainty in the case of length was 0.64% plus 0.09%. When we add them up, we have the total uncertainty in the case of area, which is equal to 0.73%. Now, how can we find the value for this percentage? The absolute uncertainty in the area is calculated as we take the uncertainty, which is 0.7 divided by 100 multiplied by the value which we already know, which is the area. So it will be 168.5. We have an uncertainty of plus minus 1.23, or if we round it off, it will be plus minus 1 centimeter cube. So the total uncertainty in the case of area of a rectangular plate is 168.5 plus minus 1 centimeter cube. In this way, we will calculate the uncertainty in the case of addition of percentage by the help of addition and subtraction rule. Numerical number 1.3. The length of a pendulum is uncertain. T, which is 100 plus minus 0.1 centimeter. If the acceleration of free fall is 9.8 plus minus 0.1 centimeter per second square. Calculate the percentage uncertainty in the time period of the pendulum. Now we have to calculate the percentage uncertainty in the case of the pendulum. We already know the formula for the time period, which is t is equal to 2 pi under root L over g. Now, for that, we have a power over here, which is under root, uh, or we can say the power of 1 by 2. Keeping that in mind, we have the data, which is length is equal to 100 plus minus 0.1 centimeter, acceleration, which is g, which is taken to be as 9.8 plus minus 0.1 centimeter per second square. We have the value, or we have to prove the percentage uncertainty in case of time. The time uncertainty we have to calculate only. Now solution. We will first calculate the uncertainty in the case of length. Percentage uncertainty in the case of length, L, is the change in length. That means the uncertainty in length, which is 0.1 centimeter, and divided by the certain length, which is 100 centimeters. So when we do it 0.1 divided by 100, and we multiply by 100 percentage, so we have the values in percentage. We multiply by 100 percentage, what do we get? 0.1%. That means this is the uncertainty in the case of length. Now in the case of g, that means acceleration due to gravity, percentage uncertainty in g, we have to find the uncertainty, which is 0.1 uncertainty, divided by the certainty, which is 9.8, and we have to multiply it by 100%. When we do it, 0.1 divided by 9.8 multiplied by 100%, we'll get 1.02%. Formula for time period, as we know, is t is equal to 2 pi under root L over g, or in this case we will write L over g raised to power 1 over 2, because we are writing down under root instead of writing down 1 over 2. Now in this case we are writing down 1 over 2. We will write it down as in the case of under root. Now, percentage uncertainty, the time period, the power has to be multiplied with the uncertainties. So 1 over 2 multiplied by, we are multiplying the uncertainties, percentage uncertainty in the case of length, plus percentage uncertainty in the case of gravitation acceleration. Putting the values, we will get 1 over 2 multiplied by 0.1, which is the uncertainty in the case of length, plus 1.02% in the case of uh, uh, acceleration due to gravity. So this is plus, let me correct it for you. So this is plus, because we are adding these two uncertainties. Now students, in this case, we have the values. Now we are going to multiply and find out the answer. It will be 1 over 2 multiplied by 1.120%. If we multiply these two values, we will get 0.56% is equal to 0.6%. So this is the percentage uncertainty in the case of this pendulum, which had a length of 100 centimeter and the acceleration due to gravity, which was 9.8 meter per second square. Numerical number 1.4. Theory suggests that a drag force depends upon viscosity of a medium, average radius of the object, and velocity of the object moving through the fluid. Derive a formula for dragging force of fluid by using dimension analysis. Hint: viscosity is equal to m L to the power minus 1 T to the power minus 1. Now this is the data which is given to us. We already know that force has a dimension, and how can we calculate it? Fd, that means drag force, is equal to ma, that means second law of Newton, where m is the mass and a is the acceleration. The unit of mass is kilogram and the unit of acceleration is meter per second square. So converting them into dimension, we'll get mlt to the power minus 2. Similarly, eta, which is the viscosity part, eta is equal to kilogram meter per to the power minus 1 and second to the power minus 1 as well. It will be written as m L to the power minus 1 and T to the power minus 1. Now the next part is radius r, which is measured in meters and its dimension are in length. Similarly, we have velocity, which is meter per second, and it will be written as L into 10 into t to the power minus 1. As we know, in the question it is given that the drag force is basically depends upon viscosity, average radius, and the velocity. So Fd, that means drag force, is directly proportional to eta to raised power if A, let's call it A, R, which is raised to power B, and V, which is raised to power C. So writing in the same dimensional form, so I have color coded it. Fd is equal to constant because it was proportional over here. Whenever we put equality sign, we have to put constant value. So we have eta to raised power A, R to raised power B, and V to raised power C. Now writing this dimension in the above equation, so Ft will be written as mlt t to the power minus 2. Eta can be written as m l to the power minus 1, t to the power minus 1, 4 raised power a because it was a over here. R can be written as in dimensional form L and it is raised to power B, and V, which is raised to power C, which is, can be written as in dimension LT to this power minus 1, which is raised to power C. Now students, I'm color coding again. I'm giving the green color to mass, blue color to length, and red color to time, so that we have a better understanding of how this basically is being compiled up. So writing the same thing with color coding, this is the drag force or FML t to the power minus 2. This is written mass, which is in eta to raise power a, L, which is raised to power minus a because this a is being multiplied inside the brackets, and similarly t to raise power minus a as well. And similarly, when this b multiplied by the length, which is a dimension of r, we can write down L to raise power b. Now students, the next part is the velocity, which is L to raise power minus t. So when c multiplied inside the bracket, it will be L to raise power c and t to raise power c as well. Now students, we are basically rearranging the whole thing so that we have m on the one side, and next to m is L, and next to L is t, which is time. In doing so, why we are doing it, that is the question, because we want to compare all of these values, what powers each value has. Mass has a value of a, and L has a value of a, b, and c, and t minus 2 has the value of a and c, sorry, minus a and c. Comparing the powers for m, for only m we will compare the powers. So it will be m to the power 1 because there is only one m is equal to m to the power a because we are comparing the two sides of the equation. So here it is m to the power 1 and here it is m to the power a. So by comparing the powers, we have a is equal to 1. We have the value of a now. We are calling it equation number 2. For L, in the case of L, we have 1 over here, minus a plus b and plus c. So L to the power 1 is equal to L to the power minus a, L to the power b, and L to the power c. So comparing the powers, we have minus a plus b and plus c is equal to a. We are calling it equation number 3. Similarly, for time we have t to the power 2 is equal to t to the power a, t to the power c. What do we get from here? Minus a minus c is equal to minus 2. We are calling this equation number 4. Putting the values of a in equation 4, Now we are putting the value of a, which is in equation 2, in equation 4. What do we get? Minus 1 minus c is equal to 2, because we are putting the value of a over here. It will be minus c is equal to minus 2 plus 1. Minus 2 plus 1 will give us the answer minus 1, because minus is on both sides, they will cancel out. We have the value c is equal to 1, which is equation number 5. Now putting the values of equation 2 and equation 5 in equation 3, because we have to find the value of b as well. So this is our equation 3. We have the value of a, we have the value of c. Now we have to find the value of b. So minus a plus b plus c is equal to 1. The value of a, we found it out to be 1 from equation 2. And the value of c, we found it out from equation number 5. So minus 1 plus b plus 1 is equal to 1. So this one and this one will cancel out, because both of them have the opposite sign. So value of b is equal to 1. We call it equation number 6. Putting values of equation 2, 5 and 6 in equation 1. We have equation 6, which is b equal to 1. We have equation 5, which is c equal to 1. And we have equation 2, which is a equal to 1. Putting values in this equation, which is ft, which is equal to constant eta raised to power a, r to raised to power b, and velocity raised to power c, or v raised to power c, we will get ft, which is equal to constant eta to raised power 1, r to raised power 1, and v to raised power 1. ft constant eta rv, which is the basically formula for the drag force. We can also represent it by ft cos. Instead of cos, we can say 6 pi eta rv. Numerical number 1.5. Suppose that the displacement of an object is related to the time according to the expression x is equal to pt square. What are the dimensions of p? Part B. The displacement is related to time as x equal to a sine 2 pi ft, where a and f are constant. Find the dimension of a. Student, we have to find the dimension of these quantities now. The given equation is x is equal to pt square. Write the dimension of x, which is distance and time. This is distance and this is time. So x is equal to pt square. So as x is the distance, so we are representing it by L, and time is basically represented as capital T in brackets, and it is a t raised power minus 2. Sorry, it is not t raised power minus 2. It is t raised power plus 2. Now, in this case, we have the values. Putting the values, the t will go to the other side, and we will get L over t square. So again over here we have t square. We will put 2 over here. So the dimension of b is L over t square, because 2 was over here, and when it got to the other side it will be 2. Now in this case we have the dimension of b, which can be written as b is equal to L into t to the power minus 2, which was derived from the previous equation, and writing them in units we have meter per second square. Now the second part, a displacement is related to time, and x is equal to a sine 2 pi f, which is frequency into time. Now, as we know, x is equal to a sine 2 pi ft. What is sine? Sine is a function of, in mathematics, which is a ratio between perpendicular over hypotenuse, as both of them are length. So both of these dimensions will cancel and they will have no dimensions. So sine has no dimension, because both of the values in sine are being cancelled out. Now we are writing the rest of the part in dimension. So x is equal to a. As we know, x was represented by the length part, so we are writing it out it as L in brackets, and that is why we have the answer. Now, part 1.6, carry out the following conversion. Calculate the density 1.33 into 10 to the power minus 7 grams per meter cube into kilograms per meter cube. Now, in this case, we have to convert this value, which is in gram per meter cube, centimeter cube, into kilogram per meter cube. So we know the density 1.33 into 10 to the power minus 7 gram per meter cube, which is equal to 1.33 into 10 to the power minus 7 grams per meter cube. This can be written as 1.33 into 10 to the power minus 7 into 10 to the power minus 3 kilogram. That means we have converted this gram into kilogram by dividing it by 1000. So if we have divided it by 1000, so we have to multiply it by 1000 as well. That multiplicative 1000 will become 1 kilogram, and the Vn of 1000 can also be written as 10 to the power minus 3. Now for the centimeter part, centimeter is equal to, uh, we can also represent it as 1 meter is equal to 100 centimeters. So we have converted this centimeter, sorry, this centimeter, which is given over here, into meters. So we can write it down as 10 to the power minus 2 meters, and which has the power of 3 because it is given centimeter cube. So it will be 1.33 into 10 to the power minus 7 into 10 to the power minus 3 kilograms per 10 to the power minus 6 meter cube, because this 3 we multiply by this minus 2. We will get 1.33 into 10 to the power minus 7 into 10 to the power 3 plus 6, because this 6, when it moves up, the negative sign is being converted into positive. It will be minus 3 plus 6, so it will be minus. So we'll put minus over here because it was minus. The new equation will become 1.33 into 10 to the power minus 7. So minus 3 plus 6, it will become 3 kilogram per meter cube. So the whole thing can be written as 1.33 into 10 to the power minus 4, because minus 7 and plus 3 will become minus 4 kilogram per meter cube. Now we have to calculate the second part, which is the B part, which is velocity is equal to 20 meter per second, and we have to convert into kilometer per hour. So 20 meter per second, we have to convert it into our kilometer per hour. So what do? We multiply by 1000 and divide by 1000, so that the multiplicative 1000 can become kilometer, and the deviant sign of 1000 can be written as it is. And second, how many seconds are there in 1 hour? We know that 1 hour contains 3600 seconds, so we divide it by 3600 seconds. What we get from here? We get 20 into 3600 seconds divided by 1000, or simply we can multiply 20 by 3.6. We will get 72 kilometer per hour. This is the conversion from meter per second to kilometer per hour. Numerical number 1.7. If there are n not numbers or Avogadro's number, which is 6.02 into 10 to the power 23 atoms in 4.0 grams of helium, what is the mass of helium atom? Now we have to calculate the mass of a helium atom. The data which is given to us, mass of helium, which is m, which is equal to 4 grams. Total number of atoms which is given to us is 6.02 into 10 to the power 23 atoms. We have to prove the mass of one atom of helium, which is equal to what? Solution. Mass of the atom, which is 6.02 into 10 to the power 23 atom, which is 4 grams, which is given to us. So for one atom, we divide 4 grams by Avogadro's number, that is 6.02 into 10 to the power 23 grams. Now we get 0.66 into 10 to the power minus 23 grams, or we can rewrite it as 6.6 into 10 to the power minus 24 grams. Alternate method can also be used. One mass of one atom is equal to molar mass divided by Avogadro's number. The procedure is going to be same. Dividing 4 grams by 6.02 into 10 to the power 23, we'll get 0.66 into 10 to the power minus 23 grams, or we can write it down as 6.6 into 10 to the power 24 grams. Numerical number 1.8. Compute the following to correct significant digits. You have to convert all of these values into significant digits, which is 3.85 meters into 3.9 meters. B part is 1023 kilograms plus 8.5489 kilograms. And C part is 22/7, which is the value of pi meters. We have to convert to significant digits. And the last part is the ratio between the mass of a proton and the mass of electron, which is 1.67 into 10 to the power minus 22 kilograms, and the mass of electron, which is given 1.9096 into 10 to the power minus 31. Now, in this case, I'm not sure about the value, but it is 10 to the power minus 27 kilograms of a mass of a proton. So this is a constant value. So you have to value it correctly. Now the first part, let us solve for the first part. A part says 3.85 meters into 3.9 meters. We multiply it, it will be 15.015 meters, or if we round it off or have the significant figures, it will be 15 meters square. In multiplication and division, the significant figures in the answer should be equal to least number of significant figures in the data. The least figure is up till 9. So here it is 2 values, we have 9. So it is 0 at the last value. So instead of writing down 0, we can simply write it down as 15 meter square. Next, B part, 1023 kilograms plus 8.5489 kilograms. We add these two values, we'll get 1031.5489 kilograms, or if we round it off as 1032 kilograms. In addition or subtraction, the answer should be up to or up least decimal place according to the given data. That means least value was up till no decimal after the point, so we are writing down the value no decimal after the point. That means the point was over here, which is 1032 kilogram. So the point ends there, so we can not write after that point. Last part of this question, if 22/7 is equal to pi, which has the value of 3.14288571, all the digits are significant because it represents a constant value ratio, circumference divided by diameter, which must be a constant number. That means all of these values are significant, having the certain amount of significance to them. Last part, which was mass of the proton divided by the mass of electron. So this is the last part of this question. The mass of a proton, as I told you, which is 1.67 into 10 to the power minus 27, as I told you over here. Kilogram divided by 9.10196 into 10 to the power minus 31 kilograms. So if we divide these two values, we will get 0.18332 into 10 to the power 4. Rearranging them or writing them in scientific form, we will get 1.8332 into 10 to the power 3. So if we have to get the significant value, the significant should contain at least the number of significant figure according to the given data, which is up till 2 digits. So 1.6, because one of them has 2 digits, so we are writing down the answer as well as in 2 digits, so it will be 1.83 into 10 to the power 3. This is the ratio between a mass of a proton and the mass of an electron. Numerical number 9, a rectangular metal plate which is 3.7 plus minus 0.01 centimeter wide and width is 7.2 plus minus 0.01 centimeter long. Find the area of a rectangle piece and uncertainty in that area. Verify the sum of the percentage uncertainty in the length and the width is equal to the percentage uncertainty. Now, in this case, we have to uh, calculate two parts. One is the uncertainty in the area, and the second part we have to verify that the sum of these two uh, percentage uncertainty is equal to the percentage uncertainty of that area. For this purpose, we will write down the solution, the data which is given to us. Width W is equal to 3.70 plus minus 0.01 centimeter. Length is equal to L, which is equal to 7.20 plus minus 0.01 centimeter. To find the area and uncertainty in that area, and we have to also prove that the percentage uncertainty of the area is equal to percentage uncertainty of the width plus percentage uncertainty of the length. Area is equal to length into width. We already know that. This is the formula for area of a rectangle of any, you can say, value which has 4 corners. But in the case of square, we have to multiply the two things because both of the sides are the same. But we are dealing with rectangle, so that is why L into width. Putting in the values, area will be equal to 7.20 into 3.70. We have the answer. Area will be equal to 26.6 centimeters square. Percentage uncertainty of width will be calculated as change in width divided by its certain width. That means the uncertainty in the width divided by the certainty in the width. So what was the uncertainty in the width? It was 0.01 divided by the certainty of the width, which is 3.70, multiply the percentage, 100 percentage. What do we get? We get the value 0.01 divided by 3.70 multiplied by 100 percentage. We will get the percentage uncertainty for width, which is equal to 0.27%. Now, percentage uncertainty in the case of length, we will get uh, uncertainty in the case of length, which is equal to 0.01 divided by certainty or certainty of the length, which is 7.2. If we multiply it by 100, what do we get? 0.14%. So 0.27 is the percentage uncertainty of width, whereas 0.14% is the uncertainty percentage of the length. The percentage uncertainty in the area, which will be percentage uncertainty in width and percentage uncertainty in length, we are adding them both. We will get percentage uncertainty is going to be 0.14 is of the length plus 0.27 of the width. We will get 0.41%, which is the uncertainty in the area. The absolute uncertainty of the area is going to be now written as A into percentage uncertainty of area divided by 100. So we are converting this percentage into its value. Putting in this formula, we will get 26.6, which we calculated, of the area, which is A, multiplied by 0.41 into divided by 100. That means we are putting in the values we will get plus minus 0.1 centimeter square. So this is the uncertainty in the area 26.6 centimeter square. Now for the second part, verify the sum of the percentage uncertainty in the length and in the width equal to the percentage uncertainty in the area. For that purpose, maximum area of the plate, we will take only the maximum part of the uncertainty, which is the plus part. So the maximum area will be 7.2 plus 0.01 into 3.7 plus 0.01. If we multiply these two values, we will get 7.21 into 3.71, which will give us the answer of the maximum area which is possible, which is 27.75 centimeter square. And similarly, we will only take the minimum part of the area, which will be 7.2 minus 0.01 into 3.70 minus 0.01, which will give us the answer after multiplying 7.19 into 3.69, it will be 26.53 centimeter cube. Now we have to take the average of these maximum and minimum value. So the area of the plate is the maximum and minimum value, the average. So A max plus A minimum divided by 2 plus minus A max minus A minimum divided by 2. That means the uncertainty maximum and minimum are also taking average, and the certainty is also taking the average part. So the maximum value is 26.75 plus 26.53 divided by 2, and the minimum part is 26.75 minus 26.53. So this is the value which we have to calculate, that one time we have to add and one time we have to minus. The answer which we have is area is equal to 26.64, which is approximately right to our previous question's value. Now, for the proof of area of uncertainty is equal to the percentage uncertainty of width plus percentage uncertainty of the length, we have to prove it. Percentage uncertainty in area is 0.11 divided by 26.62 into 100. How this came into being? We have the percentage uncertainty in the case of area, which is 0.011. We have to divide it by 26.62, which was approximately the value, and we have the value 0.41 percentage. This, let's call it equation X. The percentage uncertainty in width plus percentage uncertainty in case of length was taken to be as over here, which is 0.14 plus 0.27, and the numbers have changed their color, but the values are the same. It will be 0.41%. So if you can see from here, this 0.41% is quite equal to the percentage uncertainty which we calculated from here. It will be 0.41%. So X and Y both have the same values. So by comparing X and Y, what we get? It is proof that the percentage uncertainty which we calculated from here, that the percentage uncertainty of area is equal to the percentage uncertainty of width as well, adding the percentage uncertainty of length. So in this way we have proved and verified that the percentage uncertainty of area is equal to the percentage of the two quantities which is given to us. Thank you, students. We have done all the numericals almost, and the last part of the numerical, which is given to us, calculate the answer up to the appropriate number of the significant figures. Part A is given to us, which is 168.99 multiplied by 9. Part B is 23.5 plus 234.09, and part C is 984.25 divided by 80. So we have to find the significant figures for these all values. Part A, 168.99 multiplied by 9, as the data has the least number of significant figures is only 1, so the result will contain significant figures. We have to go up till one significant figure because there is only one, and we will neglect in the case of multiplication. In the second part, we have 1.5209 into 10 to the power 3, or we can write down 1.5 into 10 to the power 3, or because we are only writing down the significant figures and this is 5 and the next number is 1, so we have to carry 1, it will become 2 into 10 to the power 3, or we can write down this value as 2000. B part, 23.5 plus 234.09. So 23.5 plus 234.09. The answer should be up to one decimal. Why? Because we have only one decimal up till here, and because we are in addition, we have to take the least amount of decimal which we are taking in the quantity. So it will be 257.59, or we have to go up to only one decimal. We won't take these two decimal, we round it off, it will be 257.6. Part C, in the case of 984.25 divided by 80, the answer is up to the least significant figures in the data, which is three significant figures. That means the three significant figures, because of 1, 2, and 3, these are the three significant figures. We have the answer should be also in three significant figures. It will be 12.30312.5 after dividing these two values, but the answer should be three significant figures, so it will be 12.3. And in this way we have finished all the numericals of chapter, the measurements, and inshallah we'll meet again. Allah Hafiz.